Tribune that said that Dewey beat him. Anybody ever remember President Dewey?
No.
No, he didn't exist. But anyway, this was the biggest upset since 1948. This was the 538.com forecast. Now, one of the things about 538 was, unlike NBC and CNN, they were going to call it. So they said, well, we think Hillary's probably going to win Nevada. We think Donald's probably going to win Arizona. We think Hillary's probably going to win North Carolina, Florida, and New Hampshire. So they, instead of doing electoral votes, they said chance of winning. Now, the interesting thing is, they were correct. Hillary Clinton won the popular vote. So in that sense, they were correct. In the sense of the Electoral College, they messed up though. Now here's the deal. Let me skip that one. This was, by the way, in Utah, they had Evan McMullin. In their model, they had Evan McMullin getting 0.6 of an electoral vote, which obviously he couldn't do that. You either get 0 or get 6. But they predicted Donald would win Utah, had an 83% chance, he won Utah. All right, so the day of the election, unfortunately, at least my opinion, Donald Trump won, and Hillary Clinton lost. Now this was still some states undecided, but Trump was already over 270, he'd already clinched it, and he actually ended up getting about 300, which was just the opposite of that first slide of what we said. Now, as we look at this, here's the problem, okay? Now there are 50 states in the District of Columbia, so if you count the District of Columbia, there are 51 states. If you think of every state as being a simple random sample, okay, they only missed on 4 states. But those 4 states swung it, okay? This was the CNN poll, so that was the one I showed first. They had Clinton winning 268 to 204. It ended up winning Trump 306 to 232 because of these 4 states, okay? Now, when you talk about 95% of the time it works, and it fails 5% of the time, well, in this case, if you assume these are all 95% confidence intervals, they got 92% of them correct. That's pretty good. That's about what you would expect. And in fact, they did correctly predict that Hillary won the popular vote. As we look closer here, okay, they said that Hillary Clinton would win 48.1% of the vote in Florida. She won 47.7%. That's within the margin of error, right? Okay? So that poll, you would say, looks pretty good. Now here's the problem. There was only a 0.6% difference between them. They predicted Donald would get 47.5% in Florida. He outperformed, he got 49.1%. If you're talking a 3% margin of error, they missed him by 1.5, they missed her by 0.5. That's within your margin of error, okay? The problem was, they had said it was leaning Clinton. In fact, Trump won, okay? 3% margin of error, they were off by 2%. All these pollsters don't know crap, right? They actually did very well. And if you look at all 4 of these states, that's exactly what's right. They were all within what they missed by was all within the margin of error. So the fact of the matter is, it's going to fail about 5% of the time, okay? All right, so you might be part of the 5%. You might be the Florida, Michigan, North Carolina, or Pennsylvania instead of all the other states. Nobody cares that they got the Nebraska 2nd Congressional District right, because it was only worth 1 electoral vote, whereas Florida was worth 29. That's a 58-point swing in the Electoral College, just Florida, okay? So that's why, so they missed 4 states, and that's why. So the pollsters actually did a really good job. Okay? So if you want to be right more, you have to increase your margin of error. Okay? You'll be right 99% of the time, and so that's why CNN, on the one hand, you can say, well, they weren't quite as they were a little more skittish. That's why they had undecided in there, because they wanted to do that. But yeah, you're going to increase your margin of error, and they couldn't actually call it. Okay. Number 3, if you want high confidence and low margin of error, you need a much larger sample. Which means you're also going to have to spend more money. Okay? Now, some other things that you need to do. Know the statistical test. Okay? How strong is the evidence? Okay? If you say your p-value equals 0.049 versus your p-value is 0.051, okay, is there really a big difference between these two? What do you guys think? No. Technically, if you're really strict, you're going to say what on this one? Reject or do not reject? Reject. And on this one, you're going to say?
Don't reject.
Do not reject. Okay? So would you call this strong evidence? No, not really. What if you got a p-value equals 0.000001? Is that strong evidence? Who says this is strong evidence? Like nobody will raise their hand very high. 3 or 4 people. Who says it's not strong evidence? Yeah, this is really strong. Okay?
Why?
Why is that? Okay, once again, we're going to go back to the picture. What's going on with the picture? Okay, let's say it's a right-tailed test. You've got 0.05 is your alpha, right? Now, if you're at 0.049 versus 0.051, you're pretty borderline, aren't you? The area to the right is really close to your alpha. If you've got 0.001, okay, think of it this way. What's the probability of getting 7 out of 10 heads? Let's say it's about 0.05. I don't know what it is, but let's pretend it is. It's going to happen 5 times out of 100, you're going to get 7 out of 10 heads. Does that seem surprising to you? Probably not. What if you get 10 out of 10 heads? Would that be stronger evidence than 7 out of 10 heads that the person was cheating?
Yeah.
Yeah, so this is really strong evidence. This is not so strong evidence, right? Okay? So the smaller your p-value, the stronger your evidence. Okay? Let's see here. If the sample size too small, the difference may not be detected. Okay? If you got 7 out of 10 heads, that's not a very big sample size, right? What if I got 700 out of 1,000 heads? Would you say that that would be stronger evidence? Bueller?
Yeah.
Yeah, that would be a lot stronger. Okay, so you should always report your sample size with your p-value. Always report your sample size with your p-value, so the person can judge, well, they got this, but it was only 10 heads, or 10 tosses. But if they did 1,000 tosses, well, that's a little bit stronger evidence, right? Okay? All right, so I will mention this too. I'll call that A, I'll be too large sample sizes can be a problem too. Okay? let's say, for example, that hospital A, okay, we found that the average patient weighs 150.1 pounds. Let's say that hospital B, they weigh 149.9 pounds. Okay? What if I told you that the N was 100,000 people and the p-value was 0.00001? Okay? According to the p-value, is there a significant difference between hospital A and hospital B? Yeah, a highly significant difference. People in hospital B weigh 0.2 of a pound less than people in hospital A. We better put those people in hospital A on a diet, right? Okay? So we would say this is statistically significant. But my question to you is, let's look at the data. Are those numbers really different? No. So you can have a too small of a sample size, and you can actually have too large of a sample size. If you have a large one, you can say, gosh, yeah, people at hospital A definitely weigh 0.2 of a pound more than people at hospital B. It's significant. But in real life, it's probably not. So there's a difference between what we'd say clinical significance and statistical significance. Okay? So you kind of need to look at at the big picture here. All right. So, Shelley, after listening to all that, is your question answered? You're the decider, right?
I have so many questions that I have accepted they will not be answered. That's how I'll answer.
Okay, so tell me your question again. Because the whole purpose of this was
Question you were trying to answer. I'm gonna
it was about your
answer.
project. You had a question about your project.
About what about my project? Listen, I asked you two questions about my project.
Okay.
One about, is it possible to have a hypothesis test that says
One thing and your confidence interval says another. So the answer to that question is yes, it's possible, but unlikely.
okay.
They generally should agree.
Yeah, I went back and fixed the negative z-scores, because I had negative z-scores, but I was doing everything 1 minus norm s-test on Excel. So I switched it, and I went and did all the negative z-scores I did with the picture thing.
Okay. I
Because
hope
I
you
just
did it
wasn't
right.
thinking of a picture, and so I think
Okay.
I fixed it.
You should, well, I hope you fixed it the right way.
I hope
So
I
here's
fixed
the
it.
deal. By now, your project should all be done. It should be passed around to everybody. Okay? You've got, I think Bronson's by himself. You still like that? Okay, except for Bronson, you should have multiple eyes looking at this and deciding if these are right or wrong. You should be subtracting from one, should you not? Okay? This is a group project. Use your group. Everybody should contribute, because by now, if you get it wrong, because you've had 4 or 5 people looking at it, I'm gonna hammer you, okay? It should be right. You've got 5 people looking at it in some cases, okay? These should all be right, okay? It is possible, it's unlikely. So look for math mistakes that you may have made, okay? Make sure you know whether to subtract it from one or not. Draw the picture, make sure you know that, because I'm testing you guys on this on next week, okay? What was your other question, Shelley?
Have you given us a work other than the one that's on the assignment? Because last time you gave us a rubric on the assignment, and
Oh.
you used a different rubric.
Yeah.
Getting
Okay,
worse.
by the way, no, I gave
Right,
you the rubric
right.
before, but yeah, it should be the same rubric, okay? Tell you what, somebody already submitted it, okay? I'm gonna delete that submission, because I need to fix the groups before you submit it. So
No, it
whoever
wasn't.
submitted it, it's
not
not
me.
submitted. Submit it again, okay?
not us.
But don't, wait until